Hey everyone, welcome back to Math Acad, where we make math easy and fun. Today we are diving into the world of quadratic equations and their graph. We will talk about few technical words like translating, vertically stretching, vertically compressing and reflecting. So let's get started. Okay students, let's learn about the word translation, the technical word translation. For that, I have the parent graph y is equal to x square. You can see it's a parabola, opens upward, and the turning point is 0, 0. Right? Let's see what will happen when I add plus 2 to that. See, the same graph was translated upward vertically by 2 units. Right? Let's see what will happen at 3. Same graph. The parent graph was translated vertically upward by 3 units. Subtract. Minus 3. Right? What happened? The same graph was translated vertically. That means the translation is happening along y-axis. The same graph was translated vertically downward by 3 units. What happens when subtract minus 1? Okay, the same graph was translated vertically downward by 1 unit. So now we learned about vertical translation. Then we will talk about horizontal translation. For that, again I am reaching the parent graph, right? So I will write x minus 1 whole square. Right? What happened? The parent graph or y equals x square graph was translated horizontally towards right side by 1 unit. What will happen? I will change the number here. 2. The parent graph was translated along x-axis or translated horizontally towards right side by 2 units. 3. Translated horizontally by 3 units. 4. Right? Hope you could understand. In other words, when x is equal to 4, y value is 0. That's why the vertex is on the point 4, 0. Now I will do something new. I will add x plus 4. What happens? X plus 4. In the case of x plus 4 all square, the parent graph was translated horizontally or along x-axis towards left side. Let's type plus 3. So now the turning point is on the point minus 3, 0. Or the parent graph was translated horizontally along x-axis toward left side by 3 units. Right? Hope you could understand about translation. Translation means the shape is not changing. The same shape can be translated vertically or horizontally. Right? That means the same shape graph can be translated along y-axis or along x-axis. Okay, let's move to okay. Now we will move to next part. Now we are going to learn about reflection. Reflection means if there is a mirror, we can see a reflection, right? X square. So this is the parent graph, right? I'm going to multiply this by minus 1. When we multiply the function by minus 1, we get the reflection of the parent graph. So this is y equals x square, right? Y equals minus x square, right? So red color graph is the parent graph. Blue color graph is the reflected graph of red color graph. When we multiply by minus 1, the graph is reflected over x-axis. right? Let's see another example. Plus 2. Then after multiplying this by minus 2, we get minus x square minus 2, right? So the graph is reflected over x-axis. You can see that. We will take another graph, plus 4. Then here, after multiplying the above red color graph by minus 1, we get minus x square minus 4. See? The graph is reflected over x-axis. That means if the x-axis is a mirror, we get the image of that graph, right? Let's talk about another example. Plus 1. Plus 1 all square. Plus 1 whole square. So this is the parent graph. Red color graph is the parent graph. I will take the reflection of that. That means I will multiply x plus 1 whole square by minus 1. Then I get the reflected graph of the red color graph. X plus 1 all square. See? I got the reflection of red color graph. So that's all about reflection or reflected graph. Now we are going to talk about vertically stretched and vertically compressed graph, right? So for that, again, I will consider the parent graph, x square, right? So this is the parent graph. In other cases, the shape of the graph did not change, right? The same graph was translated and reflected. But in this case, the location of the graph is not changed, but the shape of the graph will be changed, right? Then we will say 2x square. See? The blue color graph is vertically stretched comparing to the parent graph. Another example, y equals 4x square, right? When the coefficient of x square is getting bigger, the graph is vertically stretched, right? When the coefficient of x square is getting increased, the graph is becoming vertically stretched. The graph is vertically stretching when the coefficient of x square is getting increasing. Let's try something different. Y is equal to half times x square. What happens? In that case, when the coefficient is between 0 and 1, the graph is vertically compressed, right? Comparing to red color graph, that means parent graph, the black color graph is vertically compressed. Let's check an example. Y is equal to 1/6 of x square. See the green graph, it's vertically compressed. Why? The coefficient of x square is between 1 and 0, right? 1 and 0. So what is the conclusion? When the coefficient of x square is increasing from 1 to infinity, the parent graph is vertically stretched. When the coefficient of x square is decreasing by 1 to 0, the parent graph is vertically compressed, right? So we will talk about something combined examples. X square plus 1, right? 2x square plus 1, 4x square plus 1, half x square plus 1, right? So when we add 1, the graphs are translated vertically by 1 unit, right? And the shape was not changed. So we will multiply each and every equation by -1. Sorry, the graphs are reflected when we multiply by -1. Second equation is multiplied by -1. Let's see what happens. It's reflected over x-axis. -1 multiplied by -1. So each and every equation is multiplied by -1. Then we get the reflection. Then the graph is reflected over x-axis, right?